Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 4, Section 5, Solving Rational Equations, Part 4. Yes, this is going on forever. Now, the last video was getting a little long, but I want you to be able to solve this, and I did say find the non-permissible values. Now, very quickly, let's do the non-permissible values first. You notice that a plus 2 keeps popping up, so a plus 2 cannot equal 0. Subtract 2 from both sides. A cannot equal minus 2. We also see a minus 2 popping up. That's up twice. A minus 2 cannot equal 0. So I add 2 to both sides. A cannot equal 2. Alright, so those are my two non-permissible values. Well, I might get one of them down here. Anyway, we're back to the equation we started on. We simplified it by multiplying by the common denominator, a plus 2 times a minus 2, and we got this mess. Now simplifying, 2 times a is 2a, 2 times minus 2 is 4, plus 4 equals minus a times a is minus a squared, minus a times 2 is minus 2a. Now I want to put everything on one side, arbitrarily. I'm going to move everything to the left, so add a squared, and add 2a. So, and the a squared, so I have 2a squared plus 4a equals 0. Ooh, I can factor stuff out. So I can factor out 2a. So here I have two solutions. 2a equals 0, or a plus 2 equals 0. So 2. A equals 0 is the solution. Alright, non-permissible values are fine. Minus 2, a equals minus 2. But my non-permissible values, we said a cannot equal minus 2. Alright, so notice that. We do all this work, and then we have to go, no, it doesn't work. Only a equals 0 is the only answer we got for this one. Evil, confusing, misleading, yes. Now, I'm going to go on. Sorry, I want you to look at this, and if you feel comfortable, we're going to go on and do a couple of word questions. Now, the word questions are only show up on the diploma, so you don't have to worry about them if you're not writing the diploma. But I'm still going to cover them anyway, because I don't want to do this video again next year. Now, when they work together, Stuart and Lucy can deliver flyers to all homes in the neighborhood in 42 minutes. When Lucy works alone, she can deliver the flyers in 13 minutes less time than Stuart can when he works alone. When Stuart works alone, how long does he take to deliver the flyers? Alright, now that's a horrible mess. I want you to realize, here what I'm trying to get is that Stuart and Lucy can work together to get the job done. Alright, now, that's not the equation you're using. I just want you to realize that's what I'm trying to set up. Now, Lucy works alone. Lucy can do it in 42 minutes. Okay? Now, time per hour. Say Lucy. Stuart. Well, Lucy is 1 in 42. Alright. Now, when Lucy, she's 13 minutes. As long as 5, 6 minutes. Less time than Stuart can work alone. Okay, sorry. My apologies, talking to myself. Trying to figure out the equation. What's the easiest way to do this? 42 minutes. Oh, sorry. My apologies. I should show you the easy way. 1 over Stuart plus 1 over Lucy equals 1 over 42. Alright? My apologies. Now, when Lucy works alone, she can deliver the flyers in 13 minutes less time than Stuart can when he works alone. So, here, Stuart takes some kind of t. Actually, let's call it x. And Lucy can deliver the flyers in 13 minutes less. So, x minus 13. Now, setting up the equation is an incredible pain in the butt. I won't be asking you to set up the equation. Well, sorry, I could ask you to set up the equation, I could ask you to solve it. I'm not doing both. But once you set up the equation like this, you're going, oh, 1 over x plus 1 over 13 equals 1 over 42. How do you solve it? Well, like any other equation, here it's something plus something, so we've got to multiply. The common denominator will be 42 times x times x minus 13. 42 times x times x minus 13, and this is 42 times x times x minus 13. As I said, I gotta have you set up the equation, the red one, or solve it, but not both. I'm doing both here just to confuse you. Now, multiplying out, that x cancels, x minus 13 cancels, and 42 cancels. So we'll be down to 42 times x minus 13 plus 42x equals x times x minus 13. Now all of a sudden, this looks a whole lot like what we were solving earlier. So I'm going to pause the recording, and I want you guys to multiply this out and solve for x. Okay? Or at least get to the quadratic part. Right? Get to the quadratic part and come back and compare answers. So, multiplying it out, I got 42x minus 546 plus 42x equals x squared minus 13x. So I moved everything to the right side, so I got x squared minus 97x plus 546. Okay, oh crap. Now, honestly, I wouldn't expect you to solve anything this nasty. Here we're getting into the realm of, no, beyond what I've asked you. But there's always somebody going, Mr. Simon, can we factor that? Yes, we can. Like I said, no, I wouldn't ask you to do this. This is getting just too nasty. Now, factors of 576. 1, 576, 2, and 546, isn't it? 546, I'm sorry. I hear you screaming at me. I'm getting old. Should be able to do this. 46. 1, 546. Now, no, I'm not going to add up. So, 546 divided by 8. 2 is 2 and 3. Not going to work. That's divided by 3. I'm still checking that's 546 divided by 3 is 3 and 182. That's not going to work. 546 divided by 4. That doesn't work. 546. I can't divide it by 5. I can divide it by 6. 6 is 91. Ooh, minus 6 and minus 91. Yes, that works. So this is x minus 6 minus 91. So x minus 6 is 0. 6 plus 6, x equals 6. X minus 91 equals 0. Plus 91. Plus 91. X equals 91. Now, that's too much work. Go back to the original equation. Stuart and Lucy can deliver flyers to all the homes in the neighborhood in 42 minutes. When Lucy works alone, she can deliver the flyers in 13 minutes less than Stuart can when he works alone. So, can Stuart deliver all the flyers in 6 minutes or 91 minutes? 91 minutes is the question. Is the answer, I should say. So we're solving for x, that is 6 minutes. If it takes both of them 42 minutes, and the answer has to be, for him by himself, has to be more than 42. So 91 0 makes sense. There's no way you can do it in 6 minutes flat. All right? So I'm going to do one more, I'll set it up, and we'll give it a try. So, it takes Bob's 2 hours to paint a large room. It takes Dave 3 hours to paint the same large room. Working together, how long will it take to paint it? Well, Bob plus Dave is, and in this instance, Bob is per hour. 1/2 and Dave is 1/3. It's much easier to solve. This should be the first question. 1/2 plus 1/3 is 1x, 1 over x. What's the common denominator? 1 over 2 plus 1 over 3 plus 1 over x. As I said, I'd either ask you to set up the equation, or I'd give you the equation and ask you to solve. Here, Bob, 1 over 2, Dave, 1 over 3 per hour. 1/2 of the job per hour. Dave does 1/3 of the job per hour. In total, how long is it taking both of them? Well, 2 and 3 is x. The common denominator is 6x. So I multiply everything by 6x. So this is 6x over 2. This is 6x over 3. This is 6x over x. And now I can stuff out. 3x, 2x, 6. 5x equals 6. 5. X is 6 over 5. Sorry, I did that kind of quickly. We're running short of time. Anyway, I want you to see set of common denominator, multiply, cancel out, and solve for x. That really should have been the first question. Anyway, that's what I expect to be able to do on the diploma. If you have questions, ask. Otherwise, work on the classic questions. Good luck.